Why do I need context managers? What do these add to my life? Well, just to review for you, we see context managers even in our most basic Python code. Every time we open a file, we use with open something as f, and then we iterate over the lines in the file. And it's a very common syntax that we see, very common use case. And maybe it was even drilled into us when we learned Python for the first time. Never just open a file and then manually close it, always use this context manager. And if we go beyond working with files to working with databases like SQLite, we might see that the connect for SQLite itself is a context manager as well. So we might say with connect to connect to our database and then do something like create a temporary table, insert some values into that, and then perform some computation. It may be the case that at some part of our script, we need to work with some temporary files or temporary directories, and we want them to clean up after themselves. We don't want these to be lingering around on disk. We don't want there to be collisions. So we'll use temp file from the standard library to create a temporary directory within which we'll create a temporary file. We'll write them to that file and we'll read something from that. And again, we're using this context manager syntax with temporary directory with name temporary file. Now, it is very much the case that our initial insight into the use of this context manager is to save ourselves from making mistakes. It is very much the case that we could operate on a file object in Python by opening the file and then manually closing it. But that means we have to remember to close the file, and I'm very forgetful. There's one thing that I will never forget, namely the index in pandas, but everything else I'm almost certain to forget, and I'm very likely to forget to close a file after I open it, and the context manager means I don't have to do this explicit affirmative closing of the file. Additionally, even if I am conscientious enough to close that file, it may be the case that I am prevented from running that line of code as a consequence of an error that occurs between the opening and the closing. And then I have to use all sorts of different contortions, try, except, in order to make sure that if I perform this setup action, the teardown action always happens no matter what, whether I forget about it or not, whether some error occurs in between the setup and the teardown. And that's our initial motivation for this context manager. It may be the case that we use context managers that are provided to us, or we go and we write our own. And so in the case of that SQLite database, we might even take the creation of that temporary table and make that a context manager on its own. Here, we have a context manager that creates a temporary table, inserts some dummy values, gives it back to you for you to do something with it, and then deletes it deletes everything from that table when you're done. And so we might package up some of these context manager steps together in some particular fashion. But why does this matter? Why do we really care about context managers? Is it really just this, setup and teardown? Well, I want to share with you that context managers provide us with 3 different perspectives on how we might improve our code or add some sophistication to our code. First perspective is we should look at a context manager and consider it to be a sequencing mechanism, one of a couple of different sequencing mechanisms that we have access to in Python. 2, we should think of context managers within the larger scope of how we convey intentionality in our program. And 3rd, we should think about how context managers encourage us strongly to structure our code so that we can manageably deal with side effects. Let me show you what I mean by that. First, if we think about a context manager, we can think about it as some sequencing mechanism. Strictly, it's about sequencing 2 operations, actually 2.5 or 3 operations. The first operation is something that you do when you enter that context, and the second operation is something you do when you exit that context. And so here you can see we have some block of code. We have some ability to enter that context and run something, some ability to exit that context and run something. And in the case of opening and closing a file, open the file, close the file, we have this deterministic desire to make sure that if we do the setup, we always do the teardown. Now, I say it's 2.5 actions because it turns out that if there is an exception that occurs somewhere in the middle of this, we can deal with that exception by, and let's clean this up. We can deal with that exception by basically having the context manager swallow the exception or not swallow the exception or do something special with that exception. So in the case of the database, maybe there's a transaction that we need to work with. And if something fails in the process of performing operations within that transaction, maybe it's the case that we will roll back that transaction. Maybe it's the case that we don't commit some files to disk or some temporary directories as permanent storage on disk if something fails. And so there's actually even a modality baked into the context manager. You perform some setup operation, and you perform one of 2 teardown operations, one on success or one on failure based on the modality that's created by whether an exception occurs in the middle. Now, one important thing to note is that for the context manager, this is very dissimilar to blocks in a language like Ruby. In a language like Ruby, the block allows you, or at least the containing structure allows you to control whether the block runs or not. It allows you to control things that happen inside the block and inject state into that block. Whereas in Python, it's quite different. Really, all the context manager is doing is adding an action here and then adding an action right afterwards if it happens to be the case that an error occurs or no error occurs. But we can't programmatically decide whether or not to run that block, and we can't really pass data between this block and the context manager. The only thing we can do is pass data down. We can say the context manager can pass data into the block. And so it's somewhat different of a structure. We're not giving up the control of when these lines of code operate. We're actually running these lines of code as they appear on the screen, and the context manager is just wrapping that with some behavior. Now, the second idea about fitting into the vocabulary of Python, well, when we talked previously about things like comprehension syntax, one of the things that we mentioned was that we prefer the use of a for loop over a comprehension if we want to convey to somebody the idea that we're performing some action repeatedly. In this code, we are clearly intending to do this print statement 10 times in a row. We are not intending to create a piece of data, and as a consequence, we may prefer the for loop because it says to somebody reading this code, do this thing 10 times. That's what this line says, and you can see, this underscore is very clear about indicating to me, I don't care about the numbers from 0 up to but not including 10. I only care that you're looping through 10 of these values. So do something 10 times. Whereas this line says, create a list using the result of the print function for each value that we don't really care about in range 10, so create 10 of those. This is misleading. Well, if we think about it, the Context Manager API provides us with a way to take some underlying mechanism in our code and to put it somewhere where it doesn't distract somebody from the intentionality, it doesn't distract somebody from what we're trying to accomplish. In other words, here for this fake database API, we might connect to the database, we might run some transactions. You could show this code to a semi-invested or semi-technical user, somebody who cares about the problem that you're trying to solve, but not intimately about the individual details, or who might know a little bit about Python, but doesn't know all the details of context managers and all the details of the protocols. And they can look at this code and say, oh, you connect to the database and you run 3 transactions and the transactions are separate. And they could even potentially give you feedback and say, you know what, this transaction needs to be run within that transaction. There's some sort of nested transaction that we need. Or it could be the case that they can tell you that maybe we don't need to, or we need to have some other layering or some other nesting, some other serializing of these operations. The idea here is, instead of cluttering up the mechanics of what actually happens in the setup and the teardown, you can express the idea of there is some setup and there is some teardown. There is some wrapping. There is something that happens before and after, and there is some nesting. And you can convey that in a way where somebody can see it very clearly in your code. This is how context managers fit into this vocabulary of Python. They convey this very simple idea in a way that somebody can look at and say, oh yeah, I can see you're doing 3 transactions in total, but 2 of them are nested, and you can visually see that by the indentation of the code. Now, here in this example, you can see a very simple context manager that I've written using a generator. And you can see that in this code, we'll talk about this in one of the future questions, but we'll talk a little bit about why it is that we might write this context manager in this particular formulation. But it's going to come up, and it's going to come up in just a moment. What I want to share with you as a separate idea, and as the third idea here, is the following. Let's say we have a data processing framework. And in that data processing framework, we're cleaning some data, we're processing some data, and we're reporting on some data. So we have some framework that looks like this. There's a clean function, a process function, a report function. We call clean to clean the data, process on the result, report on the result, and we get some summary that's produced. Now, as opposed to running on hard-coded literal values in our program, let's run this on some actual data. So we'll use our temporary directory context manager, we'll write some nonsense into that, and we'll pass it through our pipeline. We'll do a load, a clean, a process, and a report, and we've added to this the ability to load this data and to open this file and read from it. Now, as opposed to writing it in this composed fashion, we might likely see in our code that it's written in this fashion. Load the data, and then take a look at the raw data, clean the data, and then look at the resulting clean data, process that, look at the results, do the report, and then look at the summary. And there might be some behavior that we want to put in the middle to say, oh, if the raw data doesn't look valid, then we do something. If the results look one way or the other, we choose to do a report or not. And there might even be some modality for how we choose to do the summary. Do we print it to the screen? Do we email it? Do we store it somewhere? Consider this. The context manager structure is giving you the ability to perform these two paired sequenced actions, a setup and a teardown. And it usually happens to be the case that those correspond to some management of some external stateful thing, like a file. Open the file, close the file. Open the file, flush buffers if you had opened the file for writing, and then close the file. Open a database, open a cursor within that database connection, create a transaction within that, commit the transaction, close the cursor, close a database connection. And you can see that we're basically managing some stateful resource, and we're trying to do this carefully and in a controllable fashion. Well, if you think about any of the code that you write, where are the sources of churn? Usually, one of the biggest areas of churn in any of the code that you might write is the data loading and processing, the interaction with the outside world. It may be the case that there might be churn in the processing, like somebody says, oh, can you change the way in which you process this data? That definitely happens. But one big area of churn is that somebody says, oh, you know what? The opening of this file as a text file, we want to have some sort of JSON file. So here, maybe add a keyword argument called JSON and set that equal to true or false. And you know what? Oh, it turns out there's multiple JSON formats. So maybe we need you to add a modality here, which is this JSON version 2 or not? And maybe there's another modality here. Is this XML or JSON or CSV? Or do we have to perform some additional operation? Does this have a header? Or do we have to provide the header if it's CSV? What you can think is the actual interaction with the outside world is oftentimes interaction with code or with data that we don't control. And so it's the source of uncontrollable churn. We don't have the ability to say the data must be in this format. We just take the data as it's provided to us if it's provided by an external source. And we have to adapt to small changes. What that means is if we were to try to get clever and to make this code a little bit shorter and to say, you know what, why do I need to manually do the loading of this? Why don't I just have that pop up in the clean? Maybe that would just be load clean. And I'll put that load function that I had before, I'll put this thing all the way into here. And then clean can operate on a file name. And I might stack these deeper and deeper. What you can see here is we're pushing the actual interaction with the outside world deeper and deeper and deeper into our program. If that's the source of churn, then what that means is these modalities are going to have to percolate back up. So if we were to have written this load inside the clean or inside the process, which is inside the clean, maybe we even did something like this where we have pre-composed these, what you can think is we're going to have to pipe these options all the way back up. And this is going to significantly increase the amount of churn, and it's going to increase the testing burden on each one of these layers because now they have to test that additional code path, that additional modality. Fundamentally, one of the things that I like about context managers and what I use context managers for is they're a clear indication when you're working with something stateful. And because it's the case that usually these stateful resources tend to be the things which we have the least amount of assertive control over, and as a consequence tend to create the most uncontrollable churn that we have in our code, it is very much the case that we want to pull those as close to the surface level as our program as possible. To avoid this, add an argument here, but then pipe it up here, then pipe it up here, then pipe it up here, and having to create all of this churn that touches the entire control flow graph that we have, every single function as we try and push arguments down. What you can think is that a good Python program probably should have a clear entry point, and on that entry point, it should have the stacked context managers representing the context that it interacts with. Anytime you have a context manager that's not written at the top level, what you're thinking about is there's some intermediary level within my program where there's some management of resources and some lifetime of those resources. And what I like about context managers is an explicit ability to talk about and to think about what are the appropriate levels of my program where I interact with the outside world, and how is that going to create churn if, wait, I thought you said this was JSON. Now it's XML format. The data vendor says, well, that's what you're paying us for, take it or leave it. Well, to actually be able to accommodate this constant need to change your program as it needs to interact with the outside world, as the outside world changes, against whatever schedule you want it to change, against your ability to control. Now, there's one more thing I'd like to add before we move on to the next question. I think it's very interesting when we think about all of these features to think about them in the context of how big of a program would we need before these things pop up. Clearly, other people's context managers will show up in code of any size. We could have a 5-line script, and as long as it reads from a file, you're going to see that with open context manager. And so Other people's context managers are likely to show up in scripts of any size, of any sophistication. They're basically going to show up in your very first Python script all the way to the very last Python script that you write. Will they show up in your library code? Probably not, because you can think the library code probably shouldn't have this responsibility of these resources. There may be context managers that aren't necessarily associated with some outside state, but for the most part, these context managers probably should show up either at a very shallow point in your library code, or they should show up somewhere in your library code but not related to this state. They should show up in some very narrow context around something stateful or in something that's not really interacting with the outside world. Your own personal context managers. Should they show up in short scripts? Well, I could see that. I could see in a 50-line script that you might write a context manager. In a 5-line script, probably not, because the open and close, the teardown, and the setup action, you can probably just write them out. At a 50 or fewer line script, I just don't see where you're going to get the huge value out of it other than preparing for the future. And so I think that even a fairly reasonably sized script, 100 lines or so, you could see the need to know this feature and to use this feature.